Now that we have know about scalar and vectors, um, now we'll learn how to work with both of them and expressing vectors as equations. But first, we'll talk about um, how do we define a vector in a coordinate. So here I have two coordinates which are in 2D and 3D. And so looking at this OXY first, and if we have a vector with the initial point is put as is put at the origin and the endpoint um, has the coordinate xy like this, we can say the vector r is equal x y. And so if we have a vector outside like this, and we have the coordinates of the endpoint and the starting point like this, which are x2 and y2 and x1 and y1, write them as we can write vector A as equal to x2, and this is how you define a vector in a 2D coordinate. And well, the same goes for 3D. If I have um, three axes like this with the endpoint having the coordinate x, y, z, then of course we'll have the vector r is x, y, z. Now we want to express these vectors as equations, right? And so that's why we introduce unit vectors. Um, and so if I have a vector A like this, then its unit vector, which is a hat like this, we call the vector over its magnitude. And you can imagine this like this. So if I split this into equal parts, then this will be the unit vector, and it's just like velocity, which if you have a road s, then v equal s over t, right? And so what this means is that this is the road s, right? And if you split this in equal parts, then this will be v. Each of this will equal v, and you you multiply the v with t, which is that many times of v, will get you s. And so now we come back to our coordinates, and with and after knowing about unit vectors, we can write r equal. Now you can see that r is the sum of these two vectors, right? And just like we just did, this is x and x hat, right? And y multiplied with y hat. Because of that, we'll have the vector r equal this equation. And you can also do the same with a, just what you can see here, you just kind of match the x coordinate and the y coordinate to um, its to their unit vector. And the same goes with the 3D coordinates, which makes r equal x and x hat plus y hat and z hat. And now we can apply this to some calculations. First, let's talk about addition or subtraction. So I have coordinate and um, so I have so now we'll apply that into addition and subtraction. So if I here I have the coordinate and a vector c that equals the vector a plus the vector b, right? I can say that let's say these vectors have coordinates like this. Right, so c equal, so you group the xa and the xb together because they both multiply with x hat, and the same goes for y. And with subtraction is almost the same, so I can just write like this. So which means that if this instead is a minus, then it's still the same.